All right, welcome back. We are doing 7.1, ready, set, go, number 18 and 21. And so it says, name two angles of rotation for theta that have the given trig ratio of 0 between 0 and 2 pi. So this is not something, this is something that you could have gotten during the lesson, and it was very, very subtle. So I'm going to make it very clear. By the time you watch 7.3, by the time we get to 7.3, this will make a lot more sense. Okay. So this says sine of theta is root 2 over 2. So anybody have any I think it has to do with this because of this? Does anybody have I think it has to do with this because of this? Yes, it is trig. Good. But tell me more about what you know. What else do you know? Root 2 over 2. Yeah, it has to be the 45, 45, 90 triangle. So for those of you who are like, I don't see how you got the 45, 45, 90 triangle, think why someone would say that. Okay. And for me, I know it's the 45, 45, 90 triangle because whenever I get a root 2, that kind of indicates to me, I think this is a 45, 45, 90 triangle. Okay. So the way I do this is I go back to the definition of sine, which sine means opposite over hypotenuse, right? So I'm going to graph this. And then so it says the opposite is root 2 and the hypotenuse is 2. So I'm going to think that the opposite is here. Right? So then what I do is I just start labeling things. So I say this is root 2 and this is 2. And then you can use the Pythagorean theorem here to verify that it's a 45, 45, 90 triangle, which I think I'll do that right here just so that you are comfortable with it. So here goes root 2 squared plus x, this is my x, squared equals to 2 squared. So this is 4, and then root 2 squared is just 2. So that means x squared is equal to 2, which means x is root 2. Plus or minus, actually. Don't forget that this could be plus or minus, right? Whenever you take the square root, you have to include the plus or minus. Okay. Okay, so technically, this could be root 2, or this could be negative root 2. Now, normally I'd throw out that negative, but it actually makes sense for me to reflect this. If I could do a good job of drawing, that would be fantastic. Hold on. There you go. That's better. So can you imagine those two? Isn't that true? Isn't the opposite still root 2 for both of those triangles, and the hypotenuse is both 2? And then you guys would have figured out, oh, I recognize you. This is the 45, 45, 90 triangle. So this is pi over 4 here. So one of my angles is certainly pi over 4, right? What's the other angle? What's this angle right here? What's that angle? So if this is pi over 4, I always want you to think about this as being pi, right? And I want you to think about a pizza cut up into 4 slices. Ms. Johnson, where'd you get the 4 slices from? The denominator. And if you have a whole pizza and it's cut up into 4 slices, how many slices are in each pizza? A whole pizza. And you'd say 4, right? So if that's 4 pi over 4 and I took away one of these slices, right? I took away one of these slices. How much is that green theta right there? And hopefully you say, oh, Ms. Johnson, that's 3 pi over 4. Because you took away a slice, right? Does that make sense? Does that make sense? You guys comfortable with that? So here's the funny thing is if you go on here to your calculator and you go, I need, and imagine if you sine inverse to both sides, right? And you say, oh, I need the sine inverse of the square root of 2 over 2. It only gives you one answer. Now, if you're in degree land, maybe that'll help you remember. Oh, it's 45, right? It only gave you one answer. But as you can clearly see, I found two answers. So this is where you got to be, this is where you as the human are smarter than the calculator. So another way for you to figure this out is if I graph the function sine, let me go back to radians, right? Make sure that no one else is, oh, let me turn these guys off. Okay, and then, so there's sine of x, right? This guy right here, oops, he's minimized, right? And then I graph the line. Now this is going to be weird, but see if it makes sense. Y equals the square root of 2 over 2. Okay, I want to graph that line. So if you can see, does everybody see that green line? So here's my two solutions, right? So as you can see, those are the exact numbers that I got. I got pi over 4 and 3 pi over 4. So this is one way to verify your answer. But that's not all the answers. Because if I keep scrolling, right? If I keep scrolling, do you see how those two keep intersecting? And it makes sense that all of those are going to intersect because remember, sine is cyclical. So sine is going to happen over and over and over again. Does that make sense? So there you go. There's your answers one more time at pi over 4 and 3 pi over 4. So, Ms. Johnson, which way are you going to expect us to do? I'm going to expect you to do it this way because now I can write I can actually write all of the answers, and you understand why there's two answers. Okay. The last little thing I'm going to show you is, remember how I told you that sine is kind of like the y coordinate? So here, when it was, this is basically positive, I asked myself, where else is sine of an angle, I'll just say theta, positive? Specifically, I'm saying where else is the y coordinates positive? So if you think about where your y coordinates are positive, this is taking you back to 7th grade and you're like, oh, in the upper half. So in this quadrant and this quadrant. So I should have had two answers, each in the upper half of the first and the second quadrant. So if you're confused on why you're having two answers, this is why. Okay. Ms. Johnson, will all of these problems here, will they all have two answers? No, actually, they might have more. They could have less. So it's got to make sense to you. Ms. Johnson, how do you know when you're done looking for it? So, well, one of the ways is here. They gave you a bound. They said from 0 to 2 pi, find me all of your answers. So here, using my my calculator, I'm going to go from 0 to 2 pi. So that one's within 2 pi. That one's within 2 pi. And 9 pi over 4 is more than 2 pi. I can prove it to you. If I had 9 slices of pizza that were cut into fourths, that's more than 2 whole pizzas. Does that make sense? So my answers for this one is just 2. So then I always ask you, okay, well, which part of this didn't make sense? Which part of this is difficult? Now, some of you didn't recognize that this was a 45, 45, 90 triangle. That's fine because you didn't even have to know that. Because when you sine inversed it on the calculator, it would have told you 45 degrees, right? The problem with the calculator is it only gave you one of the answers. So if you're using sine inverse, you're leaning on the calculator to tell you two answers when it really can't, unless you started graphing and interpreting the graph. Okay. So there's number 18. Let's try number 21. Okay. So now that you know 2018, 21 is a little bit different. So let me pause on 21. Let's go to 20. So I want you to do number 20 right now. I'm trying to sit them so that I can draw next to them. So I want you to do number 20 right now. And I want you to find all the answers between 0 and 2 pi, and then check your answer with decimals. But show me this work here. I need to see this work here so that I know that you got it. Okay. So go ahead and pause the video, and then I will check back with you once you have number 20 finished. Okay, so now that you're back and you're checking answers with me, so I'm going to find cosine theta equals negative half. So the very first thing I do, I'm just going to say this. If you told me this is negative 0.5, which negative 0.5 and negative half are the exact same thing, I will always write cosines as fractions. Just like I would have for slope. Like I can't think of one context or one concept that I prefer using decimals than fractions. Except for maybe money, right? Okay, so the very first thing I do is I'm going to graph this, and it says cosine is negative 1, and then, so this is opposite, and this is, sorry, just kidding. This is adjacent. Sorry, I told you my favorite is sine. So I'm going to try to make everybody, just kidding. Okay, and this is hypotenuse. And so you might be asking, Ms. Johnson, who do I give the negative to? Well, the hypotenuse is never negative. So it has to go to adjacent. So the adjacent side is negative 1, which is right here, right? And then can you see the two triangles that are going to come off of here? So there's going to be one triangle up here. And then there's going to be its reflection down here. Is everybody okay with that? And then you should have said, oh, I recognize this triangle. This is a 30, 60, 90 triangle. And again, you can verify this using your calculator. So let's verify that. Let's go sine inverse of, not sine inverse. See, I told you guys, I'm always trying to make sine. So cosine inverse of negative 1/2. Notice he only gives you one answer. And I'm going to switch to degrees just to make sure. And 120 is one of them. Is one of these angles 120? Yeah. The first one is 120. Someone says, why does it go over the x-axis? So remember that your right triangles always take the elevator to the x-axis. Remember that your right triangles always go over the x-axis. So there's actually an answer for this, and I'm hoping that maybe you can come up with why. Yes, I know. So someone's like, no, I meant the reflection. Why does it go over the x-axis? But I'm hoping that you'll figure this out. And it has to do with what they gave us. Okay. So, and then I go over here. So does everybody see my two triangles? So this is a 30, 60, 90 triangle. This angle particularly is 120 degrees. So that means this guy in here must be 60 degrees. Does everybody agree with me on that? So I'm dealing with pi over 3, right? So this guy is pi over 3. So how do you write 120 in terms of pies? How do you write 120 in terms of pi? So remember that if this is a whole pi, yeah, then this would be 3 pi over 3. And I took away a slice, so now this is only 2 pi over 3. So one of my answers is 2 pi over 3. Okay. Now, what would the other one be? What would this one be? The one that I'll just draw them like this. Very good. I just need a couple more people on it. Four pi over 3. Very good. So again, it's because I have 3 pi over 3, and then I added a slice of pizza. So that's 4 pi over 3. Does that make sense? Yeah. So the question that you should be asking, Ms. Johnson, where did the two of them come from? Where did these two answers come from? So one of the places that the two answers come from is the fact that we're talking about cosine, and its cosine is negative. So the question that you should be asking yourself here would be something along the lines of this. Where or what quadrant, let's put that, what quadrant is cosine negative? So let's write the word. Right? Where is it negative? So if you know about cosine, we're really talking about the x coordinate. So in what quadrants are the x coordinates negative? In which quadrants are the x coordinates negative? Yeah, not here because x is positive. Here, x is negative because we went left. Here, x is negative because we went left. And not here because x is positive because we went right. So the fact that we have two triangles already built there, that's the reason why we have those two answers. Does that make sense? Okay. So then I want to verify my answer because I'm like, I want to know. So I'm going to graph cosine theta. So I'm going to basically graph each side. I'm going to turn off this other guy up here. I graph cosine theta, and I graph y equals negative 1/2. And you should see your answers here. 2 pi over 3, yay. And 4 pi over 3, yay. And then you look and make sure, oh wait, there's another one, Miss Johnson. And you're like 8 pi over 3. But if you know where 8 pi over 3 is, 8 pi over 3 is here, right? So here's 3 pi over 3. I started erasing, sorry. There's 3 pi over 3. Here's 6 pi over 3. And then this is 8 pi over 3 right there. So in reality, we already got that guy, but he's just more of a circle. We're just going to keep adding circles to him. Does that make sense? So you should feel pretty comfortable about graphing these, like on your graphing calculator and being able to find your answer. You should be comfortable with like drawing this out as a triangle and finding his other triangle, right? So the way we found this one, and someone asked this question really good. They said, okay, but why is it this time? Why is it reflected over the x-axis here? But over here, we reflected it over the y-axis. Does anybody have an answer to that one? Why did we reflect across the x-axis on the bottom, but across the y-axis on the top? Yeah, you have to find all the triangles. Like for this one, you had to find all the triangles whose opposite is positive square root of 2, who has a hypotenuse of 2, right? So the only places that sine is positive is in those upper quadrants. So that's why it looks like that. Down here, we had to find all the places where cosine is negative or where the adjacent side is -1. So what we ended up doing was we drew that -1 and we stopped. We went here, right? We went -1 and we paused right there. And we're like, okay, draw us triangles with a hypotenuse of 2. Well, that means we had to take elevators until we were able to have a hypotenuse of 2. Does that make sense? Yeah. Okay, next one. This one's a little bit different because it's a 0. Okay, obviously not a triangle. So the very first thing that I want to do is I want to graph this. This says my y is 0. So where is y 0? Remember, sine is similar to your y coordinate. So where is y 0? Yeah, right? It's here. So can you imagine this is a circle? This is a unit circle. And you're trying to find all the places where y equals to 0. So you're like here and here. Because this is 1, 0, and this is -1, 0. So it's those two angles. What are those two angles? Yep. It's 0, pi, and someone said 2 pi. So, yep. So it's 0. Oh, wait, what did they say? They said greater than 0. So 0 doesn't count as a solution because they said not to include him. So it's pi and 2 pi. All right. So I left you a couple here that you guys can figure out more answers. So I'm just going to go over your directions really quick. So number 1, in general, I graph the triangle. And it sounds funny that you're saying graph the triangle, right? But I literally mean use opposite or adjacent, whatever they gave you, right? Number 2, find all possible triangles. So in this case, we knew that it was going to be the two triangles were on top because we were looking for where is sine positive. Okay, down here, we knew it was on the left side because we were looking for where cosine is negative. And that's pretty much it. And then so number 3, then see if it's a special right triangle. So I'm going to put special right triangle question mark. So that's, I'm referring to 45, 45, 90 or 30, 60, 90. And that's pretty much it. So graph the triangle. The most important one is going to be the second one. Find all the possibilities. And then I'll write a check. Check using the Desmos graph and where they intersect. So this is only going to make sense if you paid attention to how I checked it. So those are kind of like my directions on doing that. Okay. Again, find the hardest part for this and then tell me like, oh, Ms. Johnson, this is where it's going to mess up. So then walk very carefully around that spot. Okay. All right. Thank you for listening.